All right, so good morning, everybody. I want to make this video today to show you just exactly what some of the ins and outs are with this static demonstration I assigned on Monday. So I know it was tricky, but I do want to give you this video today just to help help figure out the answers to these problems. So if we just go right here to the first problem, I have a neutral metal sphere is charged by induction. So, step one, a negatively charged balloon is brought near a neutral sphere. So, whenever I'm looking at these problems, I know right away that's going to give me 8 possible choices. Now, how do I eliminate half of those? I know that with static electricity, the only thing that moves are electrons. Anytime I see a proton, I ignore it. Right off the bat, I know protons do not move. So, the only thing that can move are electrons. So, I see right off the bat here, I have a negatively charged balloon. Well, what's going to happen in this case is I know if a negative balloon is brought here and electrons are the only thing that moves, the electrons in the sphere are actually going to move the opposite way of the balloon. So in this case, I'm going to have electrons start pooling over here in this part of the sphere. And then step two, while the balloon is held near the sphere is now touched. Now the sphere now becomes charged. So if I have all these electrons over here, what's going to happen is all of those electrons are going to now have the opportunity to jump to something else because it's going to be touched by a hand. So if I go ahead and check my answer and got it right. So I think one of the keys to this activity and to trying to figure all these problems out is you have to know right off the bat you are not going to get protons moving. So of those 8 choices, half are limits. You only have to deal with 4. Now, if we look at a bunch of other different scenarios, so let's if I take a look at my screen, minimize this. Let's look here at this problem. So this is very, very similar to the sphere problem I just showed you. So you have a negatively charged board right here, foam board. That means if I bring it near here, all the electrons, like charges, remember, are going to repel. So negative and negative, the electrons are going to move away and they're going to pool over here. But then all of a sudden, they have the opportunity to jump because contact is made. So the hand touches the pies in here and the electrons will jump to the hand. All right, so that's one of the problems. Let's look at another problem. Now, at any point in time in this video, feel free to pause or rewind it, look at different problems in another way. I think it's super interesting when you're looking at this stuff. So this is sort of why I'm making it. So if we look here now, different problem. Now we have a positively charged balloon. Remember, negative electrons are the only thing that can move. So if I bring a positive balloon near the sphere, all of my electrons are going to be attracted to this part. And then all of a sudden, so step number 1, a positive charged balloon is brought near the sphere. All right, all the electrons go over here. Now, while the balloon is held near the sphere is touched. The result is the sphere now becomes charged. So if we have all these electrons over here, everything that's going to be on this side of the balloon is only positive. Remember, if all the electrons are over here, this side becomes positive. So when the hand touches, all the electrons in the hand are going to get attracted to the positive side of the sphere. Okay, so one more time. Negative side here, because all of the electrons moved over, so all we have left over here is positive. So when a hand touches it, the negative electrons will get attracted to the positive side of the sphere and therefore attract and transfer over to the sphere. All right, so let's look at another problem. Boom. Now we switch it all up this time and we have a negative balloon. So step 1, negatively charged balloon is brought near the sphere. So all of my electrons are going to move to the right side over here because like charges repel. Negative, negative repel. And then all of a sudden now I have an opportunity here and the electron and something touches, all my electrons that moved over to the right side are going to jump to the hand because there is contact made. And the result is afterwards, the sphere becomes positive because all of the electrons, or at least most of the electrons have left. I shouldn't say all of them, but a large majority of them have left. Therefore, we are resulting in a positively charged sphere. So once you start to figure out the pattern of these, the problems become a little easier as you keep going, but it just takes a little bit of time to figure out the pattern. Like if the negative is here, all the negatives repel to the other side. That means this part here is going to be positive. And then all of a sudden we have contact made. If all the Electrons are over here. They're going to jump because there is contact made. And the resulting is the sphere becomes positive. All right, last problem that we will look at is, boom, this one. Now, you have a foam board that is positive, right? So foam board that's positive, so they're not touching. If they were touching, then yes, the electrons that are inside this tin are going to go into the foam board, but they're not. So all the electrons are going to pool down here towards the bottom of the pie tin. And then all of a sudden, now, if the electrons are down here, remember, the top part is going to become positive because a lot of the electrons have moved to the bottom. So when a touch happens, all it's positive up top here. The electrons inside the person's hand are going to jump onto this pie tin. That's why this works, and that is resulting in a negative charge. This one was tricky. You have to read carefully. If they actually touch, then yes, you're going to get transfer electrons. But if they're hovering like this, the electrons are going to pool down here in the bottom part, and then because they're attracted to the positive charge of the board, and then if there's all negative down on the bottom of the board, that leaves opportunity up here at the top part for it to basically be positive, and the electrons that are on someone's finger are going to be attracted to the bottom. So I hope this video helps. It's really just you getting a hold of the actual patterns that are involved. As you can hear Harper in the background, she's also very excited about static electricity and charge and all that fun stuff. But hopefully this video helps. Give this another shot. If you haven't fully submitted it, try it again. After watching this video, hopefully this becomes a little more clear. Give it another try. I really want you to go back and really try to finish all of the apprentice level stuff. So thanks for watching, and enjoy your spring break because it's coming up quick.